I welcome you all to another video. In this question, they have given that the water is flowing from one point to another via three different layers of soil. Now, let us name the points. So, we'll name the starting point as point A and ending point as point B. In between, there are 2 points where we'll name it as point C and D. And we can find out the head loss at point C, D, and B. Now, we'll write down the given data given. So L1 equal to L2 equal to L3, which is 150 mm, the length of the soil sample, and D1 equal to D2 equal to D3 is 100 mm. So area of soil is same. Also they have given the values of coefficient of permeability. K1 equal to 0.01 centimeter per second, which is zero point 0.1 millimeter per second. K2 equal to 0.003 centimeter per second, which is 0.03 millimeter per second. K3 equal to 0.03 centimeter per second, which is 0.3 millimeter per second. If you see this diagram, it is we can note that the soil is flowing, the water is flowing perpendicular to the bedding plane of the soil. So solution. So in this type of flow, the discharge will be same, whereas the hydraulic gradient and head loss will be different. Q is same, I and H will be different. Therefore, Q equal to K1 I1 A equal to K2 I2 A equal to K3 I3 A equal to K average I A. So we'll find out the K average value, which is sigma z by K. Z1 plus Z2 plus Z3 divided by Z1 by K1 plus Z2 by K2 plus Z3 by K3, which is 150 mm plus 150 mm plus 150 mm divided by 150 mm divided by 0.1 mm per second plus 150 mm divided by 0.03 mm per second plus 150 mm divided by 0.03 mm per second. So neglecting the unit values, we'll be getting this on as 450 divided by 1500 plus 5000 plus 500, which will be equal to 450 divided by 7000 mm per second. Total head loss from A to B is 560 mm, where we can denote this point as datum. To find out the value of H, we can compare this K3, that is K3 I3A will be equal to K average IA. K3 is 0.3 H by L, that will be equal to 150 into A equal to K average 450 divided by 7000 into I that is total head loss 560 divided by total length 450, total length of soil samples into A. So since A is different, we can neglect this one. 0.3 H divided by 150 equal to 560 by 7000. 0.3 H is equal to 560 into 150 divided by 7000. H will be equal to 560 into 150 divided by 7000 into 0.3 equal to 40 mm. They have given that water is moving from one point to another, that is point P to point Q, and they are asking us to find out the time taken by the water to travel from point P to point Q. Now let us write down the given data. Given thickness of aquifer T equal to 15 meter and head loss head at P equal to 55.2 meter, head at Q equal to 34.1 meter, hydraulic conductivity K is equal to 80 meter per day, porosity N is equal to 0.25, and the distance between piezometers L is equal to 2500 meter. Solution. So we know that the equation of seepage velocity Vs is equal to discharge velocity by porosity from Darcy's law. Q equal to KIA. Q by A equal to Ki. Therefore, V equal to Ki, where V is the discharge velocity. So, Vs is equal to Ki by N. Vs, which is also equal to length, that is distance traveled by time taken. So, Vs is equal to value of K 80 into I is equal to HP minus HQ divided by L into 1 by N, which is 80 into 55.2 minus 34.1 divided by L 2500 into 1 by N 0.25, which is equal to 2500 divided by time. 80 into, if we calculate this one, 55.2 minus 34.1 divided by 2500, 0.00844 into 1 by 0.25 equal to 2500 by time. Therefore, time will be equal to 2500 into 0.25 divided by 80 into 0.00844. We'll calculate this value. 2500 into 0.25 divided by 80 into 0.00844, which gives 925.651 days, which is approximately 926 days. In this question, let us write down the given data. Given, they are given that the ratio of height of two specimens is equal to LS1 by LS2, which is equal to 1.5, and diameter of two specimens DS1 by DS2 equal to 0.5. Also, ratio of constant head applied on two specimens HS1 by HS2 equal to 2. Also, they have mentioned that discharge from both the specimen is equal, which is the key point here. They asked us to find out the ratio of permeability of soil specimen. Solution. Since discharge is same, from Darcy's law, K1 I1 A1 equal to K2 I2 A2. K1 I1 will be equal to H1 by LS1 into A1 will be equal to LS1 into, A1 will be equal to pi by 4 ds1 whole square equal to K2 I2, which is H2 by LS2, and pi by 4 ds2 whole square. So H2 and H1 are the head at point 1 and 2, sample 1 and 2, and L be the length of sample 1, and LS2 will be the length of sample 2. So from this, cancelling out pi by 4, K1 by K2 equal to, we'll take from the left hand side to right hand side, K1 by K2 will be equal to LS1 by LS2 into H2 by H1 into DS2 by DS1 whole square, which will be equal to LS1 by LS2 1.5 into H2 by H1, that is HS2 by HS1, that is 1 by 2 into DS2 by DS1, that is 1 by 0.5 the whole square. We'll calculate this one. 1.5 by 2 divided by 0.25, which will be equal to 3. K1 by K2 equal to 3. if you see this question, it's a kind of direct question where they have asked us to find out the effective stress in point P and Q. So we'll directly write out the solution because given data is already there in the diagram. So the surcharge Q is equal to 70 kilonewton per meter square at point P. Total stress sigma is equal to Q plus 3 gamma, which is Q plus gamma Z. Okay, Q it is equal to 70 plus 3 into gamma it is equal to 18, which gives us 3 into 18, 124 kilonewton per meter square. Pore water pressure U is equal to, see, if you see the diagram, the water table is present at point P. So above point P, there is no water table. So pore water pressure will be equal to hydrostatic pore pressure plus excess pore pressure. Here hydrostatic pore pressure is equal to 0. So 0 plus excess pore pressure is nothing but your surcharge 70, which gives us 70 kilonewton per meter square. Now effective stress sigma dash is equal to sigma minus u, which gives 124 minus 70 is 54 kilonewton per meter square. Now at point Q, total stress which is equal to Q plus 3 gamma, which is okay, Q plus Z gamma plus Z gamma saturated, which is Q plus 3 gamma plus 4 gamma saturated. Q is equal to 70 plus 3 gamma is equal to 3 into 18 plus 4 saturated is equal to 4 into 20, which gives you 124 plus 4 into 20, 80, which gives you 204 kilonewton per meter square. Pore water pressure U is equal to hydrostatic pore pressure plus excess pore pressure. So above point Q, water table is present at a depth of 4 meter. So hydrostatic pore pressure will be Z gamma W plus excess pore pressure is nothing but a surcharge, which is 4 into 9.81. They have given the gamma W as 9.81. Yes, 4 into 9.81 plus 70, which gives 4 into 9.81 plus 70, 109.81 109.24 kilonewton per meter square. Effective stress sigma dash is equal to sigma minus u, which is 204 minus 109.24, which gives 204 minus 109.24, 94.76 kilonewton per meter square. So at Q it is 94.76 and P it is 54. So let us see the options. So option C is the right answer. If you see this question, the water is flowing upwards in the soil sample, and they have asked us to find out the effective stress at point A. So since the water is flowing upwards, the sand is said to be in, just a minute, since water flowing upwards, the sand is in submerged state. If it is flowing downwards, you can say it is in a saturated state, where the continuous application of water leads the sand to lose its strength and it makes it to flow. So we can say that the sand is in submerged state. And from the question from the diagram they have given that the head loss H is equal to 1.2 meter, and they've asked us to find out the effective stress at point A. So we need to find out the effective stress at point A, which is 1.5 meter from the top, because stress acts downwards. Okay, so effective stress is nothing but total stress minus pore water pressure. Effective stress will be total stress, that is Z gamma submerged minus pore water pressure. Pore water pressure is nothing but the uh, water present at the soil sample, which is at point A. So it is I Z gamma W. Why we have taken I? Since there is a head loss, we have taken I. Okay, so which is equal to Z gamma sub 1.5 into submerged unit weight. Have they given any submerged unit weight of the sand? The void ratio and specific gravity. Okay, they haven't given this submerged unit weight, where we need to calculate it. Minus I, which is H by L into Z into gamma W. So 1.5 gamma sub minus head loss is 1.2 divided by length of the sample 2.5 into Z, that is 1.5 into gamma W. They have given gamma W as 10. So 1.5 gamma submerged is equal to minus 1.2 into 1.5 into 10 divided by 2.5, 7.2. Sigma dash is equal to 1.5 gamma sub minus 7.2. If you see the question, they have given the void ratio and specific gravity of sand. So with this, we need to calculate the submerged unit weight. So from the functional relationship, we know that gamma submerged is equal to G minus 1 by 1 plus E gamma W, which is G 2.7 and E they have given 0.58. 2.7 minus 1 by 1 plus 0.58, gamma W is 10. So gamma submerged is equal to 1.7 divided by 1.58. 10.594. 10.759 kilonewton per meter square. Sorry, kilonewton per meter cube. Okay. So if you substitute the gamma sub in equation 1, we get effective stress is equal to 1.5 into 10.76 minus 7.2. 1.5 into 10.76 minus 7.2, which is 8.94 kilonewton per meter square.